Hi everyone, this is the Radko explaining. In today's video, we are looking at how to find the Laplace transform of this question. So this question is coming from advanced calculus and it is under Laplace transforms. Alright, so now how can you get the Laplace transform of this? So for you to get the Laplace transform of this question, you need to first check what is given in that Laplace. So in this case, you are going to realize that you are given something like this. So you are given something like sine A plus B. So these are trigonometric identities that you need to note before you solve that question. So you are given sine A plus B, which is given as a sine of A cos of B plus sine of B cos of A. So this is the identity that you are going to use in order for you to get the Laplace transform of this question given on top there. So what we simply need to do here is to replace what is given there into this trigonometric identity in order for you to get the Laplace of this question. So what we're going to do is to say, therefore, we have the Laplace of this, which is sine AT plus B, would be equal to, we are now replacing this into this identity. So whenever there is A, we are putting the angle which is AT, and whenever there is B, we put angle B. So we say this is equal to sine, so you can say this is equal to Laplace of sine, where there is A, you put AT, then cos B, we put a B, so you have cos B. Alright, or you can use the small letter as it is used there, then plus, you come here plus sine B, we are putting the B, so we have sine B, and then cos, what is our A? Our A is AT, so you put AT, like that. Now from here, you are going to say, Laplace of this plus that is the same as saying you have the Laplace, we can separate them, we can say this, the Laplace times this, we are going to have Laplace of sine AT cos B, okay, like this, then plus, also this is the same as Laplace of, we put it in a separate bracket, which is going to be sine of B cos of AT, like that. Then from here, what you're going to do then is we've seen that B is common. So B is common. If B is common, we can factor it out. In other words, cos B is a constant, so we can factor that constant. So you have, this is going to be cos B is a constant, and then you remain with Laplace of sine AT, like this, and then plus. Here what is common, what is our constant there? Our constant is sine B, so sine B is a constant, and then you remain with what? A cos AT, like that. So from here, what you need to do is to use the Laplace transforms. So the Laplace transform of this is known. Laplace transform of this also is known. So it's just a matter of you replacing in those transforms, and then you'll be able to get your final answer. So you have your cos B, then Laplace of sine AT is given as A over A squared plus A squared, then plus. Here also you do the same, sine B is our constant, then we get the Laplace of cos AT. So Laplace of cos AT is given as S over S squared plus A squared, like this. So from here what you're going to do is to multiply cos B times A, you got cos B times A, you got A cos B over S squared plus A squared, then plus. You come here also, you multiply sine B times S is going to give you S sine B over S squared plus A squared. Alright, so in this case, you've seen that you have the same denominator, so you can just add the numerators or simply just end there as your final answer. Okay, so this becomes our final answer, or what I'm saying is, if you want, you can just pick, because you know that you have the same denominator, so you can simply just get the denominator, which is S squared plus A squared, and then add the numerators, which are a cos b plus a sin b. A cos b plus s sin b. So this becomes our final answer. So that's how you can be able to get the Laplace of that function. So it's just a matter of you knowing the identity that you're supposed to use in that Laplace transform in order for you to reduce it to that particular answer. Thank you so much for watching this video. Don't forget to follow my page for more videos.